From terrestrial sensing and terrestrial computing to space sensing and space computing, the space computing constellation has opened up a new pattern for the space economy. On May 14th, China launched 12 satellites with a single rocket. This is the world's first space computing constellation. The three-body computing constellation is equipped with an 8 billion parameter space-based model, which is capable of achieving inter-satellite connection throughout the orbit and plans to build a space computing infrastructure on a scale of 1,000 satellites. This is the first time that humans have deployed large-scale computing power in space. Why build computing satellites? What are their uses? Why is space computing regarded as the next-generation technological high ground? Let's seek answers to these questions. Frequent satellite launch enthusiasts know that traditional satellite technologies mainly focus on communication, navigation, and remote sensing. Take observation satellites as an example. After being launched into space, they observe and photograph the Earth, generating up to 500 gigabytes of data daily. However, due to limitations such as bandwidth and ground station overpass time, only about 20 gigabytes of this data can be transmitted back to Earth in a timely manner for analysis by terrestrial computers. Most valuable information is thus lost in space. An American company has provided inspiration by claiming that its AI satellites can enhance geospatial intelligence decision-making efficiency by 8 times. The logic is simple: send computing power into space. With AI capabilities, satellites can automatically analyze captured images and generate reports, taking as little as 90 minutes. It should be noted that traditional intelligence analysis methods may take hours or even days to complete. The company has already secured orders from the U.S. military to provide the European-based army with hourly updates on the movements of armored units along the Russia-Ukraine border. Yes, hourly updates. This has completely transformed battlefield transparency and response speed. However, China's stellar computing plan is even more ambitious. It aims to launch a constellation of 2,800 computing satellites, which will then interconnect with more than 100 ground-based computing centers to create an air-ground integrated computing network covering the Earth and establish the world's first space computing system. If the stellar computing plan is successfully implemented step by step, it will trigger a revolution in the computing power industry that defies imagination. The emergence of space computing constellations will reshape the modern warfare landscape. In military reconnaissance and surveillance, with space computing constellations, numerous remote sensing satellites can interconnect via inter-satellite laser communication links, transmitting captured images at ultra-high speeds of 100 gigabits per second in real time to the space computing constellation. Advanced algorithms carried on the satellites can rapidly identify critical information in the images, such as the status of aircraft carrier formations or military facility deployments, within seconds or minutes, significantly enhancing the timeliness and accuracy of military reconnaissance and providing more timely and precise intelligence support for combat decision-making. The high-speed and stable communication network built by space computing constellations ensures smooth information transmission between different combat units. In complex electromagnetic environments, traditional communication satellites are vulnerable to interference, but space computing constellations can optimize and adjust communication signals in real time through their powerful computing and anti-jamming capabilities, ensuring the stability of communication links. For example, in joint operations involving multiple military branches, combat information from each service can be quickly and accurately shared through space computing constellations to achieve highly efficient coordinated operations. The strike precision of precision-guided weapons directly affects combat effectiveness, and space computing constellations can leverage their powerful computing capabilities and real-time data processing advantages to provide more accurate target positioning and tracking information for such weapons. During missile flight, the constellation can dynamically adjust the missile's trajectory based on real-time battlefield conditions, enabling the missile to hit targets more accurately and significantly enhancing strike effectiveness. In future wars, space computing constellations will become a key pillar of China's military capabilities, a major milestone since the establishment of China's informationized forces. By integrating multiple functions such as reconnaissance, communication, and navigation, they provide comprehensive, real-time battlefield situational awareness for operational command. In the rapidly evolving dynamics of modern warfare, where victory or defeat can be decided in an instant, those who can make faster and more accurate decisions will gain the initiative.